Session 5, A Short History of Ion Propulsion. To counter the popular notion even of those who should know better, that ion propulsion is science fiction belonging in the same category as anti-gravity, we present this brief history of ion propulsion and the giants in the field of rocketry who advanced our understanding of ion propulsion both in space and in our major focus, the atmosphere. There has been a fundamental limitation on the thrust and efficiency that an ion engine can produce caused by the interactions of the ions and the electric fields that accelerate those ions. We have dubbed this phenomena the brick wall of ion propulsion. We will discuss this phenomena in more detail in presentations to follow. To show just how difficult this brick wall has been to climb over, this brief history of what others have done in the past is useful. In this review we use the term ion rocket to denote those devices that carry their own reaction mass and typically operate in the vacuum of space. And ion jet for those devices that obtain their reaction mass from the medium they are immersed in, typically the Earth's atmosphere. Also in this review, we also use the terms ion propulsion in space or vacuum ion propulsion, VIP, and atmospheric ion propulsion, AIP. Ion propulsion in space. The earliest researchers in ion propulsion were all rocket scientists interested in space exploration, but they laid the groundwork for ion propulsion in the atmosphere, so we begin with them. Dr. Robert Hutchings Goddard published many articles on the use of rockets in space and on the concept of multi-stage rockets. In addition to his writings and teaching, he actually built and experimented with many of his designs. For his early work in liquid fuel rockets both as a theoretician, inventor, and experimenter, Goddard is generally acknowledged to be the father of modern rocketry. But he should also be acknowledged as the father of electrostatic propulsion as well. He was the first person in 1905 to propose using electrostatic fields to accelerate charged particles, which is the basic principle of all ion rockets and jet engines. Goddard based this proposal on the high velocities measured for what we now know are electrons but in 1905 were called cathode rays. He proposed this method of propulsion 8 years before the Rutherford-Bower model of the atom was published, when the concept of an ion was still unknown. It was only 3 years after publication of the Rutherford-Bower model of the atom in 1913 that Goddard filed the first electrostatic propulsion patent in 1917, which was issued in 1921. Considering the time it takes to file a patent, it is clear that Goddard was aware of most breakthroughs in physics almost as soon as they were made. In Goddard's patent he accelerated every electron, and he was therefore proposing a rocket motor. His focus was totally oriented to space applications, and as such he was trying to minimize the amount of reaction mass used to produce thrust by accelerating every electron to its maximum velocity. The Rutherford-Bower model of the atom was presented by Niels Bohr and Ernest Rutherford in 1913. It is a system consisting of a small, dense nucleus surrounded by orbiting electrons. Ernest Rutherford was born at Brightwater, near Nelson, New Zealand on August 30, 1871. The Geiger-Marsden experiments, also called the Rutherford Goldfoil experiment, were a series of experiments performed between 1908 and 1913 at the physical laboratories of the University of Manchester by Hans Geiger and Ernest Marsden under the direction of Ernest Rutherford. From these experiments Rutherford was able to deduce that there was a small region within the atom that contained all of the positive charge and most of its mass, which later became known as the nucleus of the atom. Surrounding this nucleus were an equal number of negative electrons in orbit around the nucleus, determining the overall size of the atom. Niels Henrik David Bohr was born in Copenhagen, Denmark, on October 7, 1885. Niels Bohr built upon the Rutherford model by combining it with quantum mechanics that determined the actual orbits of the electrons. In a paper published in 1921, Bohr showed that the chemical properties of each element were largely determined by the number of electrons in the outer orbits of its atoms. The Rutherford-Bohr model of the atom has now been accepted as the true structure of all atoms, that is, having a dense nucleus of positive charges surrounded by an equal number of orbiting electrons, each having a negative charge. With this model it became clear that you could make any neutral atom have a net positive or negative charge by either adding or removing an electron, thus creating a charged particle, what we now call an ion. Hermann Oberth was born on June 25, 1894 in Transylvania, Romania, but became a German citizen later in life and is generally considered to be German. His contributions were similar to and later than Goddard's, but he claimed his work was independent of Goddard's. While Goddard spent most of his time experimenting, Oberth spent most of his time publicizing his work and later teaching others, including Wernher von Braun. In his 1929 book on space travel, Oberth devoted a full chapter to electric propulsion and seemed to be the first person to realize that you did not have to ionize every atom and molecule of the reaction mass but only a small portion, and that collisions of the ions with the neutral atoms and molecules of the reaction mass will transfer energy and momentum through collisions with these other molecules, resulting in greater ion propulsion energy efficiency, laying the groundwork for ion propulsion in the atmosphere. While there were other advances being made in ion propulsion, it was not until 1948 that Wernher von Braun, leading a group of German rocket scientists brought to the United States after World War II and now working for the United States Army at White Sands, New Mexico, ordered a full-scale study of electric propulsion systems for use in space applications. Ernst Stullinger was also a German rocket scientist who worked closely with Wernher von Braun and Hermann Oberth in the United States and took part in von Braun's 1948 study of electric propulsion. Unlike most other rocket scientists, Stullinger also had a degree in electrical engineering. In addition to working together to advance manned spaceflight, von Braun and Stullinger collaborated with Walt Disney Pictures to produce 3 films, Man in Space and Man and the Moon in 1955, and Mars and Beyond in 1957. Stullinger worked as a technical consultant for these films and appears on screen in Mars and Beyond, where he discusses the use of cesium-ion rockets to make the journey to Mars and beyond.
An atomic-powered spaceship has been suggested by a leading scientist in the rocket and guided missile field, Dr. Ernst Stullinger, who for some years has been working closely with the rocket engineer, Dr. Wernher von Braun. This atomic electric spaceship features a revolutionary new principle that will make possible the long trip to Mars with only a small expenditure of fuel. In the thrust chamber, a platinum grid is electrically charged. The metallic element cesium is vaporized and blown through the white-hot grid. This ionizes the cesium atoms, and they are then electrically blasted out into space at the rate of billions per second. This thrust pushes the ship in the opposite direction. The atomic electric spaceship can operate continuously for a period of years.
I suspect that it was not a coincidence that in 1957, the Air Force Office of Scientific Research issued the first electric propulsion research grants. By 1959, the Office of Naval Research, the Army Ballistic Missile Agency and the Advanced Research Projects Agency had all issued research grants in electric propulsion. By 1960, almost every large rocket and aircraft firm had an active electric propulsion program. Ion propulsion in space. But even in space, they all hit the brick wall of exceedingly low amounts of thrust. By the early 1980s, interest in ion propulsion even in space had all but disappeared. It was not until the mid-1990s that it was realized that even with its low thrust, ion propulsion in space could still be very useful, keeping satellites properly positioned. Later it was also realized that because unmanned missions can take years, an ion engine providing low thrust continuously can accelerate a vehicle to higher velocities than a chemical rocket can with a short burst of high thrust, both using the same amount of reaction mass. It is for this reason that there is now a renewed interest in ion propulsion in space. Ion propulsion in the atmosphere. The real story of ion propulsion in the atmosphere begins in 1921 with an experiment performed by Thomas Townsend Brown. Thomas Townsend Brown was born in Zanesville, Ohio in 1905. He was interested in electronics from early childhood, and his wealthy parents bought him his own experimental equipment. At the age of 16 he had obtained a Coolidge X-ray tube which contained 2 asymmetrical electrodes used to generate X-rays. He found that when he placed the tube on a scale with the positive electrode pointing up and applied power to it, It became lighter. With the positive electrode pointing down, it became heavier. This led him to believe that he had discovered a new interaction between electric and gravitational fields. In 1923, at the age of 18, he collaborated with Paul Alfred Biefeld at Denison University on this electrogravimetric force in what later became known as the Biefeld-Brown effect. Throughout his career, Brown tried to convince everyone that this electrogravimetric force was real. Lacking any real theory as to how this interaction worked and faced with questionable experimental results that were not reproducible, he was for the most part unsuccessful. His belief in UFOs also did not help his cause. His research did, however, spawn continuing research by others who believed in the Biefeld-Brown effect, who formed the asymmetrical capacitor group, as opposed to those who did not believe, forming the Lifter group of researchers investigating electrostatic propulsion. Those who believed in the Biefeld-Brown effect, including Brown himself, came up with the idea that his electrogravimetric force was created by what he termed an asymmetrical capacitor. Most electrical capacitors are constructed with a dielectric insulator sandwiched between two conducting electrodes. Normally these two electrodes are the same size, but Brown proposed that when the sizes were unequal, that his electrogravimetric force would be generated. Many experiments performed using these asymmetrical capacitors seemed to show this force, but when the experiments were performed in a vacuum, the thrust all but disappeared. In 1980, under an Air Force contract, Robert Talley performed tests on asymmetrical capacitors in a vacuum and concluded that any residual force observed was likely caused by electrostatic interactions with the vacuum container, and that the thrust measured was so small that it was of no value as a means of propulsion in space. Still, the small residual force that sometimes remained in vacuum experiments gave those who wanted to believe, including NASA as late as 2005, hope that there was still the possibility that this force was real, and if it was, it would be a ticket to the stars. But because non-Newtonian thrust has never been observed, those who would have us believe it does must present us with absolute proof, and unfortunately for the Biefeld-Brown effect and asymmetrical capacitors, no one could or can supply proof because it simply does not exist. One of Brown's patents was for a device that is now called a lifter. It is a very simple device consisting of a thin wire separated and aligned with the edge of a wide foil electrode. If sufficient voltage is applied between the wire and the foil, a corona will form around the wire consisting of ionized air that is then accelerated by the electric field between the two electrodes, thereby producing thrust. Major Alexander de Seversky was a pioneer in aviation going all the way back to the 1920s. De Seversky was the founder of the Seversky Aircraft Company, which later became Republic Aviation. In the early 1960s, he conducted research on what is essentially a lifter, which he called an ionocraft. From the articles written at the time, it would appear that unlike Thomas Townsend Brown, de Seversky knew that thrust was produced by the acceleration of the ions by the electric field. De Seversky put in a great deal of effort trying to make it work, but it is clear that he too hit the brick wall and then moved on to other things. The ionocraft was the Popular Mechanics cover story in August of 1964. 50 years later, there is still no practical ion propulsion in the atmosphere. During the 1960s, there were many people and many patents issued, all based on the lifter design. In every case, these were attempts to increase the thrust and efficiency by slight variations in layout, size, and shape of the electrodes. A careful study of all these patents shows that all of these investigators did not understand the true cause of the brick wall. By the end of the 20th century, there were only a few independent researchers still experimenting with lifters. With the advent of the internet, there was a resurgence of interest in lifters by many small independent researchers. J. L. Naughton spent many years experimenting with lifters, and much of his work and experimental data was later used by Blaze Labs to continue studying lifters after it appears that Naughton came up against the brick wall and moved on. After this report, in 2005, Lockheed proposed using ion propulsion in DARPA's Walrus project, a huge blimp that could carry 1,000 soldiers and all their equipment at one time. Soon the use of ion propulsion was dropped, and later the Walrus itself as being impractical. In 2009, NASA again published a report on more lifter experiments repeating the same experiments done by Brown, Seversky, Naughton, and Blaze Labs, with the same results, and once again hitting the brick wall and adding little to the advancement of ion propulsion. In 2013 MIT published results of their lifter experiments, and again, like the NASA 2009 report, added no new knowledge about ion propulsion, and after hitting the brick wall they ended their study with exactly the same conclusion that de Seversky came to almost 50 years earlier, that ion propulsion in the atmosphere holds the promise of being the most efficient method of producing thrust in the atmosphere but needs more work, and any meaningful results are years away. As can be seen by all these researchers who achieved mixed results, ion propulsion even in the atmosphere is not science fiction. It is real and obeys all the laws of motion and all the conservation laws. Asymmetrical capacitors that violate Newton's laws of motion are not real. These first 5 sessions of this seminar provide the background that we believe is necessary for everyone to understand what we are trying to accomplish with this seminar. Session 1, the introduction, gave an overview of what we will be presenting in this seminar and why it is important to you. Session 2, who we are, gave our qualifications and tried to show that we are not members of the tinfoil hat brigade, that our work and what we are trying to do here is grounded in real science and is not just a fantasy or wishful thinking. Session 3, the timeline of these past 20 years and how hard we have tried to bring atmospheric ion propulsion to the world as safely as possible. Session 4, fundraising, illustrates just how far we have fallen as a nation compared to when we were a young nation leading the world in technological advancement, and how negligent so many have been with their groupthink and lack of due diligence. Session 5, a brief history of ion propulsion, tried to show just how extensive and diverse the effort has been to make ion propulsion a reality, from the early rocket scientists, government agencies, amateur researchers, and even a movie studio. The next 5 sessions will try to show everyone what atmospheric ion propulsion can bring to the world when it is developed, and how it can greatly enhance the quality of everyone's life while saving so many lives. Up next, Session 6. The 5th level of civilization. Follow us on X at charged_motion. Follow us on YouTube at charged-motion. Our website is at charged-motion.com. You can contact us at contact@charged-motion.com. If you would like to support us, please go to our website and click support in the menu.